So if you haven't already watched the video on kind of glucagon and low blood sugar, there's a video on that. But just to give you a brief overview, again, of these pieces of maintaining glucose homeostasis, we've got two arms to this. We've got sort of the low blood sugar arm, which deals with glucagon and the mobilization of free glucose from glycogen. And again, I encourage you to watch that video first. This video is really talking about sort of the high blood sugar arm and what happens when your pancreas secretes insulin in response to high blood sugar, because high blood sugar is toxic. It's really problematic to have high levels of blood sugar for long periods of time. And so your pancreas is going to have this insulin response and produce insulin. So we're going to go through the normal sort of progression of things first. And then we'll talk about what happens with somebody who's a type 1 diabetic. And then when you have type 2 diabetes, which is really insulin resistance. Okay, so let's walk through the normal process first here for high blood sugar and how your body responds. So we're going to walk through it on this picture first, and then we'll kind of go through and relabel it. So we're going to start here and talk about what happens with this external stimulus. You've got blood sugar levels that have risen, largely because of food that has been consumed, okay? Your pancreas is going to have a response here. Your pancreas is going to release insulin into the blood. The beta cells of your pancreas produce insulin, release it into the bloodstream as a signal for high blood sugar levels. 3 and 4 here respond to two different cell types that are going to be responsible for essentially serving as glucose sinks. They're going to be able to pull in glucose from the bloodstream, and the importance of that is they're going to allow those blood sugar levels then to fall. Okay, so those are sort of the 4 steps of sort of normal blood sugar elevation response. So let's write down sort of what those are. Again, this first step is that we've got a signal for increased levels of blood glucose. Then the second thing that's going to happen is your pancreas is going to produce insulin. So we're going to have increased levels of insulin. Okay, now steps 3 and 4, and we're going to actually add a 5th step on here, is what happens once 3 and 4 have been exhausted. So step 3 here is where you're going to have your muscle cells get involved. And we've talked about some of the details of this, but what happens is we're going to have GLUT4 receptors that are on muscle cells. Those are insulin sensitive, so those GLUT4 receptors are going to come to the surface of your muscle cells. They're going to bring in glucose, and then they're going to first store it as glycogen. Okay, so that's sort of the intent of the muscle arm of this, is they're going to take and they're going to bring in glucose, and then they're going to store it as glycogen. The number 4 arm for this here is really involving the liver. So the liver does the same kind of a process. It's going to bring glucose in, but it does it through a different receptor. And in a future learning unit, we're going to talk about the differences between these two receptors, but this is a GLUT2 receptor. And GLUT2 receptors are always present. So with these receptors being always present, okay, they're going to do the same thing, bring in glucose, and they're going to store it as glycogen. And so what we really do here is we replenish these short-term reserves. And again, if you need a little refresher as to glycogen and sort of that arm, there's another video on that. But we've got these short-term reserves. They're intended to be able to last about 12 hours. So we replenish these short-term reserves. And they're supposed to last about 12 hours. So that's sort of the normal insulin response, okay? And then what we're going to have is well, what if these two arms have been filled up? What if those glycogen reserves have been maxed out? They are not unlimited in their capacity. So then we sort of move into this 5th arm here. And this 5th arm, and it's not really something that's written here, but this 5th arm is, well, what if you have excess glucose? So if you've got excess glucose still, you're going to have high levels of insulin. And what we're going to have a signal for then is we are going to do triglyceride synthesis. This is something that still happens in the liver, okay? So we're going to still have the liver sort of participate in this, but triglyceride synthesis is going to occur in the liver. And then what happens is we're synthesizing these triglycerides, which are then going to be stored in adipose tissue. So something just to kind of highlight here. Insulin is, again, this signal for high blood sugar. So we've got insulin is a signal for elevated glucose levels. Now, what happens is there's two things related to fat that are related to insulin. So we are going to be activating fat storage when we have elevated levels of insulin. Okay, and we are going to be inhibiting fat breakdown. And this should make sense, right? If you've got high blood sugar levels, high insulin levels, we should be saying if there's excess, we need to get rid of that toxic glucose and we're going to store it as adipose tissue. But we're also living in this soup of food, so we need to be inhibiting fat breakdown. So all of this makes sense. And when we have insulin levels that can fluctuate, this process happens normally. Okay, so let's map on a couple of sort of normal situations here. Let's imagine that you are a type 1 diabetic. Type 1 diabetics do not have the ability to produce insulin. So their pancreas has not been able to produce insulin. And so that we are no longer going to be able to do anything downstream of this. So muscle cells are not going to be able to take up glucose because they don't have that insulin signal to bring those GLUT4 receptors to the surface. Again, your liver has the ability to sort of take in some glucose, but it's not as effective in being able to sort of fully manage that elevation in blood sugar levels. So type 1 diabetics cannot produce that insulin. Okay, that's in contrast to type 2 diabetics. So again, type 2 diabetics, we're going to add on a number 6 here. So, and I should say that, our 5 is there. We don't have a 5 on our picture here, but step 5 is really what we do with excess blood sugar. This 6th step really operates here, okay? So type 2 diabetics, really in this step, we're going to say that we've got earmuffs. So we've got earmuffs at step 6. And what that means is that's where this resistance sort of piece comes in. So insulin resistance means the signal is there, but we're not listening to it. Okay? So here's the impacts of that. Well, when we don't have the ability to listen to that signal, that means the biochemistry that was supposed to happen at step 3 with muscle cells taking up blood sugar, that is inhibited because we're not listening to that signal. Those GLUT4 receptors do not go to the surface and muscle cells are not able to pull in that glucose. And that's an important piece because muscle cells now think that they're starving because they're not pulling in that glucose soup that is sitting outside. We have a similar but somewhat blunted response on the liver being able to pull in, because remember, those receptors are always present on the liver. So the liver is going to be still pulling in glucose, might be affected a little bit, but not as much as we're not going to be able to have that glucose sink in our muscle cells. And importantly, what this really means is we are going to have a significant elevation in step 5. Okay, and step 5, remember, was excess blood sugar being able to be converted into triglycerides and then stored as adipose tissue. And so we really only have this as an option. So this is the only option that we really have to manage high blood sugar. Okay, so we're going to convert it into fat. The other option, and we do see this with diabetics, is we can pee it out. So the other option is to pee it out. Okay? And we do see this with diabetics. Diabetics frequently have high sugar levels in their in their urine because that's their body's way of trying to get rid of these toxic levels of glucose. So reminding us that elevated levels of blood glucose are toxic. Move this over here so I can get my toxic word in here. Elevated levels of glucose are toxic. So this is toxic. Very pro-inflammatory. On a long-term basis, this is what causes a lot of the complicating things that we see with people who are diabetic, okay? And this is particularly problematic with type 2 diabetes. So this continued elevation of blood sugar is a hallmark, again, of both type 1, but then type 2 diabetes. Okay, so one of the things too to mention that can happen with type 2 diabetes, so let's again run through what's happening with somebody who is type 2 diabetic. What's happening is they're having elevated blood sugar levels. Their pancreas starts secreting normal levels of insulin. But as we see at step 6, we've got earmuffs on. We're not listening to that signal. So what happens is your body continues producing more and more and more insulin, shouting louder with this signal, trying to get your cells to hear it. Now, why this is problematic is eventually people who are type 2 diabetic can become type 1. Okay, they become type 1 because their pancreas just burns itself out. So just a little story here to kind of make sure to highlight, if all that you're looking at is elevated blood sugar levels as a metric for whether or not somebody is diabetic, particularly if somebody is type 2 diabetic, you are looking so far downstream that that's really problematic. So see if this makes sense, right? What happens early on with somebody who's becoming insulin resistant is their blood sugar levels will remain normal, because what happens is their pancreas is producing more and more insulin, shouting louder and louder and louder to make sure that we don't have those toxic levels of blood sugar. What we really need to be asking is not, does somebody have elevated blood sugar levels? We need to be asking, do they have elevated insulin levels? Because elevated insulin levels are that early marker of the fact that we are becoming insulin resistant. And so we need to really ask the question, if we have elevated insulin levels but still have low blood sugar levels, our pancreas is still working, and it's only once our pancreas really stops being able to work that those glucose levels are going to creep up, or we become so insulin resistant that even that shout is not allowing that blood sugar to be pulled into our cells. Okay? All right, but what are our solutions for these problems? And so when we think about solutions, I want you to think about 3 arms. We've got diet, we've got exercise, and we've got prescription. Okay, so let's first talk about the diet piece. So with our diet piece, the best way in type 2 diabetes is absolutely reversible, or especially early on, if you reduce or eliminate carbohydrates that will allow you to restore your insulin sensitivity. Because you don't have that high level of blood sugar that you need to be screaming at with high levels of insulin, your pancreas can have an opportunity to rest and get back to sort of a normal insulin sensitivity. So diet can be really important for that. Exercise is really important too, okay? And here's where that's going to help. Exercise can help with this number 3. Now, it's in an insulin insensitive way. Okay, we're not going to get into the details of this, but exercise really can help muscle cells increase the amount of glucose that they're able to take up. Okay, so exercise can be a way to increase the insulin sensitivity of your muscle cells. Remember, muscle is a really important tissue that serves as a glucose sink. We need to make sure that we don't have elevated blood glucose levels. So any place that we can sort of deposit that into is going to be good. So increasing muscle mass as you get older is a really important mechanism for staving off type 2 diabetes. And the last piece, and I'm going to zoom in here because I'm running out of space and I want to make sure to have enough room to write clearly. When we think about prescriptions, we want to think about a drug called metformin. It is one of the most prescribed drugs kind of in general, and it works because it does 2 things. It increases insulin sensitivity and it inhibits gluconeogenesis. So it increases insulin sensitivity and it inhibits gluconeogenesis. So I talk about gluconeogenesis on the glycogen sort of story when we talk about the ability of low blood sugar to be remedied by a top-down approach, breaking down glycogen into glucose, or a bottom-up approach, where we take non-carbohydrate precursors, and gluconeogenesis is the process that converts those into glucose. Now, again, if you are having issues with high blood sugar, you don't want sort of your body's natural processes to be making more glucose. And again, the problem with this earmuffs, with this sort of insulin resistance, if you will, is your body thinks it's starving, even though it's living in a soup of sugar in your bloodstream. And so what's going to happen is all of these things that are designed to try to help with that, your cells think that they're starving, is it's going to be trying to, well, let's make glucose from scratch. Okay, it's going to have all of these other mechanisms that it's trying. It's going to upregulate your hunger hormones because it thinks it's starving. Okay, so lots of things here that highlight a normal insulin response and how it goes wrong with both type 1 diabetes and type 2 diabetes.